Fresco beverage. We're live. It's 9:55. I'm a little late, but Milo's here, sleeping as usual. He always wants to be up here. He wants to be part of it. He likes to hear me talk to the live crew. So hopefully everybody's doing good this morning. It's Friday, getting ready for the weekend. Can't wait till the day is over and get to see my wife and maybe go on a date night. I think we're going to go watch a football game. Should be fun stuff. But we're not here for that. We're here to talk about like car guy stuff. So go get your projects done. I need some time. Hopefully this weekend I'll be able to get some painting done. What I need to do is get the video done early. So I think all I'll have to do is probably stay up late, really late one night and prep the video that I have for the next day and get it loaded so that it will launch all by itself. I'll just schedule it. And then I can take part of that day, I want to get the heads and the block out and get them in the sun so that they warm up, and then I can paint them all. And so the poll for today is going to be this. Start a poll. Should I use GLYP? I think it's Glyptol. I think that's how to spell it. Doing that big block SS 396, SS 396, the 375 horse 396 heads. So the poll for today is, should I use, I'm going to paint the outsides all orange because, you know, Chevy orange, you got to do that on a big block, especially an early one like that, the 396 version or the 375 horse 396 version. But a lot of times, especially the old school stuff, the boomer coating for the lifter valley is Glyptol. So should I use Glyptol in the lifter valley on the block? And then also you use it like in the spring area on the cylinder head. So let me know what you guys think about the using Glyptol on there. It helps make a smooth surface so the oil drain is better. Obviously, you could also go in and radius the holes and stuff. I'm not building a race motor. I'm just building a reproduction of the L78 375 horse 396 just to kind of see what it does. I haven't built a 396. 396s are cool. There are other guys, kind of big blocks, not quite as other guys as a 366 or even a 427, which would probably be more common of the two tall deck like truck blocks. The 366 would be more other guys, although less effective. It'd be better to do a 427 because a bigger one for a truck application, obviously, is going to be better and make more power. But we're going to do Glyptol on that. And today we're talking about linkage, talking about getting linked in. We're talking about linkage because when I've done lots and lots of testing on multiple carburetor induction systems, whether it's a tunnel I am on a big block or small block, or whatever. The photo that I have up, the thumbnail that I have up is the dual quad setup on a blower. And if you have a good size blower, like the smaller ones, the 177s and the 142s, these little mini blowers, those are almost always a single carburetor. I don't know if I've seen one that has a Dominator style flange on it with these little small blowers. But the thing is, with any sort of blower, what you want to do a positive displacement to any sort of positive displacement blower, whether it's a roots blower or a twin screw blower, is you want to have as much air going into it. So bigger carburetors, if you're running a carbureted version, the carburetor also helps cooling. You got to run fuel through these roots blowers to help lubricate them, but it also helps cooling. You get good charge cooling. They love E85. If you're running through that, you can run nitrous through it. All that's good. When you go to these bigger blowers, like the one that I showed, it was either a 671 or an 871. I don't remember which one it was. But all of these bigger ones, the 671, 871, all the way up to 1471 stuff, that's almost always multiple carburetor stuff. They have adapters for the inlet of the supercharger so that you could put a single 4150, you could put a single 4500 Dominator style carburetor, but more often they run dual quads on it, and they do run better. Although I do have to say, as going off on a tangent, I have run a 671 supercharger on a very, very mild 350, like one of these Target Master style GM crate motors, and we ran a blower on it, and it made as much power just running. I had two carburetors on, but we disconnected one of them, and it made as much power on one carburetor as it did on two because the motor just didn't make any power. I mean, it was like a 400 or 450 horsepower motor with the 671 on it, to give you an idea of how bad the thing was. So it didn't need all that carburation, but dual quads obviously look better on a tunnel ram. They look better. I have a photo that I showed on one of these live feeds, I think, with a single 4-barrel tunnel ram, which I think is probably a distribution nightmare unless you have the nice, you know, angled top section for the tunnel ram, so that we get, you know, we can get better distribution and have the air and fuel go out to the outer runners as well. I still think it's probably not ideal. The dual quad seems to work better. And on this blower, the dual quad stuff is very cool. It makes good power. You know, it looks right. If you have a big blower sticking out of the hood, you also have to have 2 carburetors sticking out of the hood, because that's part of the presence, part of the proper presentation of a big roots blower and or a tunnel ram, and having it, you know, on your truck or car or boat or pro street, you know, whatever it is. My pet peeve for all of these things is not the blower. It's not having 2 carburetors. It's actually the linkage. Of all of the things that take time when you're setting them up, especially if you're setting up a brand new setup from out of the box, is the linkage, is the carburetor linkage. Dual quad linkage needs to be redesigned. We need to start a movement, and I have a design for it already. There needs to be a redesign. These little fine splined shafts are ridiculous for setting these up. The problem is on a dual quad linkage, you have to have at least 3 of these arms. So you have to have 1 going to each carburetor, and then you also have to one that you activate to activate and turn this rod so that it activates, you know, pulls the throttle linkage on both carburetors. And setting all that up, getting the positions right, getting the stops on all of these, getting them lined up on exactly the right fine spline so that they're all the same, so that they start and end in the same position. It's just silly, because if you get it wrong, especially if you put all 3 of them on and the inside one is wrong, which is not uncommon, because that's the one that's going to activate the levers. And so if you hook up all your throttle linkage and go, hey, look, I've got this much movement. Oh, now it's hitting something, or it doesn't open the carburetors enough, which is very, very common on all of these linkage setups. Now I have to go take all of these off and then move the other one, or just rotate the bar and then put these other ones on. So it's just a big rigmarole. It's just a big time suck, basically. It's very time consuming to get it to work right, which is why at West Tech, there's a setup that's already done. It's something that we can usually just bolt on. It has little extensions off of it that just bolt onto the carburetor bases, and then you tighten that on. The linkages are already the same. They already work with what we have as a common Morse cable attachment, but it's a little bit different for different tunnel rams and different blowers, depending on where the bracket for the throttle is going to mount and stuff. And so it is a little bit. And the thing that needs to be different about it are the arms that you put on here that activate the throttle on the carburetors. Those arms need to be 2 pieces. It's very, very simple. Right now, they slide on a spline shaft, and then you tighten a bolt and it squeezes them down so that they stay in place. That's all great. That would be assuming that you don't have to spend a lot of time, like you put it on right the first time. And that almost never happens if anybody's done this. All you need to do is make those arms 2 pieces, a clamshell, so they bolt together. So if they're not on the right spot, you just unbolt it and move it and then clamshell it back together. You don't need these things don't need to be ultra fine either. But even if they are, if this is a 2-piece clamshell setup and it still can bolt together the same way, all it does is the bolt is holding it together and it clamshells together, and it's not going to move. It can even be an interlocking front and then come back down, and then the bolt goes through, so it could never come apart. It's a really simple design, and that's all you have to do to make working initially with the throttle linkage on a dual quad tunnel ram or a dual quad supercharger setup like the one in the thumbnail photo. It would just make life easier. And I can't believe that this kind of linkage had to be originally designed back in like the 50s. So why haven't we seen a better linkage design? And we've bought many of them, and all of the ones I've seen are the same thing. They're the same common shaft. It's splined. They have the same metal arms that are also splined. And it's just a design whose time has come. It needs to change, and somebody needs to redesign that. And really, you could take the existing piece and just cut it and make it two piece. It's just like it's just really simple. And you still utilize most of what's there, because the stops with the little Allen screws on them that slide on to the unsplined part of the shaft, all that could stay the same, because you use a lot of these existing stuff. Really, the only thing that you need to design is the arms that slide on. And even the design of that is going to be almost identical to what's already there. Instead of a one piece, it's just going to be a two piece. So Holly or Wyand or all of you people out there that are making these linkage setups, redo that for me, please, so that we can make life easier. It's time. It's time for it to be better. It's been 60 something years or whatever. It's time to make it different. It's time to make it better. So that's my tirade for this morning. Let's see how our poll is doing on our, I keep wanting to say Monday motivation, but it's not Monday, it's Friday. It's morning motivation. Should I use Glyptol in the lifter rally? 69% saying yes, and 31% saying no. There's always the no people. I don't know if I've ever done, I don't think I did it on, didn't do that on my Engine Masters motor. Maybe I left power on the table by not having Glyptol on there. We also need to talk about the tuning stuff. That's still going strong. Everybody wants to see the same sort of tuning video and test procedure done on supercharged motors. They also wanted to see the same kind of testing in, not the tuning part of it, but the spark plug test on a supercharged motor or turbocharged motor. And we went over last night the obvious reasons why it's not going to be that same kind of test, at least not to those extremes. On a supercharged motor, we would want to be a lot more careful when we're doing that. And also, as we talked about with the turbocharged and supercharged stuff, there's not a reason to chase plug gap on that. Just put the plug gap down so it doesn't misfire, and then go on about your business with making all the power that you want with any amount of boost that you can put at it. It will work out just fine. So let's see what you got. What kind of projects you guys? E3s raise the compression by taking up more volume. Yep, we've talked about that. So we just need giant sized plugs. And if we had a plug big enough, maybe a plug that screwed in from the other side so that it would fill in most of the chamber, and then that would be good. Although changing plugs would be problematic because you have to take the head off. But still, what is it worth to you? Old school painted valley trick. Yep, I disagree with the E3 plugs. I don't think E3 plugs are worth anything. We've run them at the dyno before and not seen any power. But I do want to do another dedicated test on it just to find out. What video was a carb attached to the throttle body? And saw a picture of it in the Cadillac Supercharger video. The video is up. I ran a carburetor on top of a tune port. I basically welded a carb spacer on top of a tune port plenum, and we obviously cut the hole in it and tried to run a carburetor on top of that, and it didn't work very well. Did not work very well. Aaron, what's up? I'm at work and someone says E3 spark plugs give you more horsepower. I think maybe that's more because they sponsor Top Fuel than anything, but getting a new head for my H22 comes with a Skunk 2 intake manifold and flat face Skunk 2 valves, 35-degree valve job, fresh from the machine shop. Nice. Your other head was cracked. Tom, where did that head crack at? Where did that H22 head crack at? And did it do it because of detonation or boost, or what was the deal? Aaron, I was able to pull apart the Mopar RT heads I picked up. And they're heavy, but that's your wrenching for today. Old school painted valley trick works. It works for better oil shedding or better oil drain back. I like NGK plugs. I like whatever plug is on sale. A lot of times I'll just go over. Well, a lot of times when we get stuff from the wrecking yard, we use the wrecking yard plugs. I've even used wrecking yard plugs, factory plugs, AC Delco plugs, whatever came with the LS motor. We've used those projected tips, hot heat range, and we've run boost on them. Not usually a lot, but It's already there. The plug is working. Let's just do that rather than have to go to the store and buy new plugs for it. That's the problem with that. That's always an issue with me with these wrecking yard motors. If you go get a wrecking yard motor, whatever you pay for it, $300, $400, $500, whatever it is, because we try to buy stripped motors now. We take all the accessories off and take everything off that they charge extra for. So we just get the things that we need, and we get that motor, and you get that for that motor. You get that motor for that price, and you bring it back, and we're trying to run it on the dyno. But any amount of money that I have to spend on it, a new water pump, spark plugs, oil is already bad enough. I always have to buy oil for it. So oil and filter right off the bat, that's making the motor. And as a percentage of the race motor that I just bought from the wrecking yard, even oil, 5 quarts of oil and a filter now has upped the price percentage wise a big amount from the wrecking yard. And if I have to buy like what I would call big things, head gaskets or valve springs or push rods, or that's why I make sure it has all the sensors. Because if you have to buy, not the knock sensors, I just throw those away normally, but the cam sensor and crank sensor, the coolant temp sensor, I almost never get the air temp sensors, but I need to make sure that that's part of the motor that I get from the wrecking yard from now on, because we almost never run air sensors. We just zero that out so that it's not making any adjustment on the dyno. But it would be good to have those and to actually have more of those. But TPS sensors, all those things, if I have to get any of those, all of a sudden it's fairly easy to increase the cost of your race motor by 50%. It's actually, if you're going to rebuild it, it's easy to make it now double or triple what the original cost was. So that gets more expensive. And I just don't like that more as a philosophical percentage amount than the actual money. Because buying oil and filter, you have to do that stuff. But then when you look at it like that's $50 or $30 or whatever it is, in comparison, I just raised it like 10 or 15% the original cost. And that's too much money. We can't have that. 6-pack TBI Magnum with a turbocharger. That would be good. Bigfoot, you said yes this time, so you won't be dead to me anymore. That's not a good place to be. You don't want to be hanging out with that crowd. That's a gateway. That's a gateway crowd. You check out some of the VW dual carb linkage setups. Some of those super simple, and some of those seem very complicated. I have seen a couple of them that we've ran. The one time I ran VW stuff on an engine dyno, wasn't my engine dyno, wasn't my motor. All I was there was to help with, we were running basically what our DCOE looking, we use them as side drafts also, but also as down drafts. They are EFI setups that you use that look exactly like a Weber carburetor back in the day. I think since then, the company that had them that I was helping was bought by Borla maybe, and maybe they're using them, but they look really cool. The injectors are inside, and it's a fairly cool setup. And we ran it. We wanted to show the VW guys because they're like, oh no, these were 48 or 50 millimeters or something. Oh no, those aren't big enough for what we're doing. We're like, yeah, these flow. I don't know what the flow rate was, 300 CFM per hole or whatever. And so we're like, look, they're enough to support any power that you're making with any VW. No, we need 58s or 60s or whatever, because we're running all these Webers and these giant manifolds and stuff. And then we showed them, hey, look, this does that. And that's the one where I showed them the change in runner length. I said, you can make a lot more power than this. You can make a lot more average power. Oh no, I won this championship engine building thing, and this motor that I put together made all this power, and I had this giant ported manifold and 58 or 60 or 100 millimeter Weber carburetors where the guy uses. I'm like, that's the wrong way to do it. I said, I don't know anything about VW motors. I said, but I can improve your power a lot. No, you're not a VW guy. You don't know what you're talking about. So I just went in and took our stacks and just grabbed some tubing and taped together some tubing and put it in there. And I said, okay, now do your dyno test. And it picked up like 30 foot-pounds of torque. And it picked up power everywhere in the range that we were running it, because we were only running it to like 6,500 RPM or something. And this was an old, I think a Stutska dyno too, because he was adjusting the load, because they couldn't even run a sweep. They could just do a stationary load and then do another stationary load and another stationary load. I'm like, this is really ludicrous. And we can't load it for very long because it's an air-cooled motor and it will overheat and break itself. I'm like, this is not a good setup. But you should have seen him when I said, okay, when you roll into this, I said, it's going to be different. And he's like, no, it's not going to make less power. I said, oh no, it's not going to. And you should have seen when they loaded it at like 3,000 RPM, whatever start was. He's like, I'm like, yeah, this is a lot. I'm like, yeah, that's what Runnerlink does. But I digress. I wonder if you'll get laser plugs working. How about lightsaber plugs? How are you trying to mount the carbs on the supercharger, inline or 90 degrees sideways? On which supercharger? The one that I have on the photo? They just mount on top of the blower. I know people who've used the paint, but has anyone had any of it flake off? I don't think the Glyptol comes off. I've seen that on motors run for a really, really long time. And when we take the motors apart on race motors and stuff, it's still there, and it's nothing. None of it has come off. I would imagine, like any paint or coating surface, the surface prep probably is critical for that. Oh, the H22 crack from overheating. That's not uncommon. Overheating will cause that. So, Fascist, you want me to add all of these other things for polls? I really can't do that. It only gives me the option of yes or no. But it's just a game. We're just playing. It's not a critical thing. Carl, you're here for confession. I discovered a flaw in my injector static flow testing after building 2 jobs. Should I refund my customers completely or only refund partially, charge for cleaning? What was your flaw? Did you clean them? And if you did, and you're charging them for that, then that's fine. And if you flowed them, they got information, right? Ever seen Z-wire neon spark wire? I haven't. Does it like light up? Because that would be cool. People would love that in a video if you could make those spark plugs light up. Because we see that. It's cool to see when you shut the light off, like you do a turbo thing, you see the exhaust glowing. That's neat. But also you can do that like on an NA motor. But if you can see arcing from one plug wire over to ground or something, that's also really cool. Karlov, what do they rate the injector flow at? What pressure do they rate it at? And what are you flowing at? Glyptol is used to dip electric armatures. Yeah, I think that's why it was designed. It's very tough. I haven't got a chance to go look at the turbo burn barrels yet. I kind of want to see that. Yeah, and wire does light up. It was Tesla's design. Oh, cool. What are you doing, Mano? What are you doing? Hello. What do you think? What do you think on the poll? Huh? Think yes or no? What do you think? I want when you energize the ignition that I want it to go, like when your lightsaber extends. So how are we doing? Oh, we're getting closer towards 50-50 here. 59% are saying yes and 41% are saying no. What do others injectors test at? Is there a percentage change? I think is what Douglas is getting at. Have you tested like a known entity, other kind of injector, and found that there's a variation there in your flow bench versus what they're rated at? Do you have the right voltage going to? I mean, if it's an ASNU thing, they should be consistent. Yeah, that's another good point, Sykes. What are you using to flow it with? Maybe the fluid is different. Maybe you're not using the proper viscoelastic polymer. You wouldn't be using that. The flow rate would not be very good with that. Yeah, jumped up to 60% on the yes. I do like the photo that I have up on the dual quad stuff. It was really cool. I really like when I did the single. So I disconnected one of the throttles on it just because it was such low horsepower thing, and then I started thinking, what must the distribution be like? But actually, a supercharger is a fairly good mixer. So if it's drawing fuel from that one, and it's all going into a big open common plenum. If you've seen these lower manifolds on these blower motors, typical. Most of them are like this. They're really short runners, kind of like the factory 3800 intake is like that. All of the factory blower ones that I've seen are like that. They're just because of space constraints. There's no room for them to put any runner length in. So we have a just big open plenum. So I think that lends itself with carburetor, even offsetting one way to one side or the other, because when you have dual quads, if you were only running one of them, it would be offset to one side. You'd think, oh, well, all the fuel and air, I guess, is going to go into the front four or the back four, depending on which carburetor you're using. But that actually doesn't happen. So it works pretty well. 13.5 volts, static flow testing voltage. That should be good. You can do that or spend hours with a Dremel to smooth everything out. Yeah, that works too. I've seen guys go in and knock all of the sharp edges off the block. I've seen them detail blocks like that. That is very, very time consuming. When guys are doing it right, they go in and chase every thread to make sure that it's right. When I'm doing, because I'm just more concerned about the time than anything. When I'm chasing threads, a lot of times I'll put the thread chaser. I'll start it by hand and then I'll run it in with a drill and run it out. And I know people are going, oh, but that's just going to break it. No, you can do it. So just like when I'm putting bolts on and off with the Milwaukee gun. First of all, I don't normally use one that has very much power. The one that I use is only designed to basically do the time consuming work of undoing the bolt after it's untightened. So if you notice in a lot of the videos, when I take cylinder heads off, hits the bolts or studs, I will undo them by hand with a long breaker bar, and then I will zip them all out with a gun. So it's the same kind of thing. I'm just running them in and running them back out with the chase. And I do it not so, wah, wah, wah. I'm not doing that. I'm just running it in easy and running it out easy. And that way I can feel if there's any edge. When you're chasing threads like that, there's normally not a problem. You're not tapping it because that's already been done. Those threads should already be good. But I like, buzzing them in and out. You can even chamfer all the tops of them if you really want to get crazy about it. You can dress the edge of every, lifter bore. You can go in and deburr the block on the inside and on the underside where the mains are and all of that. And you can even do it on the outside if you want to make it look all pretty, but it's, it's a lot of time and it's a lot of effort. Don Hampton used single plane manifolds to make his own blower manifolds. Those work well, and that's exactly what I want to do on the Pontiac. On the Trophy 4-cylinder, rather than use that very, very cool, and apparently I'm going to be a chump for not getting this intake manifold that Freiberger told me about, but I just want to put a regular intake manifold on like a dual plane. We're going to cap one side, and then I just want to mount an adapter plate, and the adapter plate would be easy to bolt the blower on. And so on that adapter plate, I can make that either just a common plate or a little bit of a box. And then that will allow me to mount the supercharger. Hopefully, I haven't done the distance thing yet, but it will hopefully allow me to mount some kind of supercharger on there with the right snout length. And then just all I need to do is line the snout length up with the crank pulley, basically. Just need to get that set and then bolt the blower in place. And then all the wonderful boost when we spin it will go down into the thing. And I also need to do it with a supercharger that I can run a carburetor on. So we want something with probably a top mount. Although, does anybody know, has anybody run these M90 Eatons with a carburetor going into the backside of the blower? Have people done that? When I was a kid working at a machine shop, that's very cool. I spent hours and hours polishing lifter valleys and deburring blocks. Paint was a lifesaver. Yeah, it'd be a lot easier to do that. And for a lot of these things, for just like stock kinds of rebuilds, for a race motor, that attention to detail, or for a guy where that's a critical thing, that sort of attention to detail might be important. For putting together a stock or a rebuild kind of stock motor, why would you do that? You use a 471, yes, or a 371. All those would be good. I haven't seen. I need to look and see. I'll go take a look right now. $471 blowers for sale. Let's see what we got. Here's an eBay one. Parts only $2.99. That's pretty cheap. Oh, how to rebuild blowers. That's not good. Ford Flathead 471 blower, $5,000. Yeah, no. Gonna hard pass on that. 471 blower supercharger carb adapter for a Holly. Rotor kits. I think what I would do, see here's an Offenhauser custom old school big block Chevy blower supercharger intake manifold. So it is an adapter plate, literally an adapter plate for a carbureted intake manifold, it looks like. 1961 fuel system Stromberg 97 carburetor injection SCTA VTG moon tanks blower. Interesting. Oh, that's looks like it's just a so $29. That just must be a magazine or something. 471 blower intake gasket screen. I wonder if that works or if that hurts power. So I'm seeing lots of parts for them, but not actual blowers. So intake blower spacers, interesting. Ooh, a high helix 871. Probably not. A 4PK AMR 500 mini roots compressor blower turbocharger. It's all of those things, right? That's $163. I could just run 2 of those, right? Does anybody know how much these AMR 500 blowers, how much power they're good for? They sure sell a lot of those. Lots of those for sale. Polished blowers for sale. They need to make an AMR 1000 blower, so that something that's twice as big as that one that's available for sale. I would answer if I knew what Glyptol was. It's just a coating, like paint the inside of the lifter valley. Any chance of finding a bigger turbo for a 80 to 81 Pontiac Trans Am? Yeah, that should be not hard at all. I've run 5/8 tap through rusty threads with a 1/2 inch impact because it's too difficult with a tap handle. So you've tapped it then, and not just chased the threads. Steve, you have an 81 Turbo TA? Probably easier to stack the supercharger on a TBI. Bet you find a 471. I wonder if Freiberger has one of those. Go to R&P blower service. So let's go look that up. What happened here? R&P blower service, heating systems and professional. Let's see. Welcome to blower drive service. Ooh, a 471 blower from blower drive service, $3,000. No, that's not helping. So I'm not really finding anything on them. Let's see. R&P. Richard, when do you plan on doing the small turbo test? Which one is that? We got the car 8-figure Y. They sold it. They replaced 5 gears with 411s and never crushed the collar. So the rear end is bad. Is that what you're saying? He's in Waterloo. I thought that I saw that. All I see is a Manta thing for them. I don't see a page or anything. Oh, well, we'll find them later. It's not important. I'm not going to buy one of the superchargers anyway. I'm putting together a stock bottom end LQ4 821 heads, Amazon sheet metal intake, 102 millimeter throttle body. The motor goes in my 89 Blazer drag truck. I plan to use an S475 next year. What cam and ring gap should be like 28. And how much power are you wanting to? Well, you have a S480 or S475. The intake manifold that you picked is going to be a little soft down low because it's a short runner deal. And that might not be a problem if you're having traction. I don't know what trans you have in that, and I don't know what converter you have in it. But I don't know. The comp 454 cam probably would work. The 54-454-11 camshaft would probably be good for an LQ4. I honestly think you could top out the S475. If you don't have a lot of gear in it, you don't have a lot of converter in it, I would go smaller than that. Casey's out. Casey, did you get your? Well, you won't. You might get them today. So how is our poll doing? 58% are saying yes. That should coat the valley. I'm not going to coat it with paint, that's for sure. But I was thinking about doing Glyptol on it. RV cam. You could put something small in there. Even if you put a truck Norris cam in there, it would or maybe the new hot rod cam also might be something to look at. From Brian Tooley Racing, the hot rod cam and that combination with an S475 would allow you to get everything that S475 would have to offer. I thought you were talking about testing the GT35 and GT45. Yeah, I'm going to do that. Maxing them out. Or is that a fantasy that I have? Also have a 98 SVT Cobra convertible. Feels just as fast. Karlov, what injector machine are you using? Would that coating be beneficial for the backs of intake valves or direct injection motor? I don't think so. I think you would put something else on there. And I think you'd have to have something that's not a spray on like that. I think you'd have to have something that's electrostatic or heated or something. I think I have seen coated valves before, but I don't know if, again, I think that all the racing, the professional series racing, I don't think anybody's doing that anymore. Richard, any chance of getting a bigger turbo for my TA that will bolt directly to that manifold? It's a weird 3-bolt flange, right? I don't know if there's any direct upgrade for that. Oh, I'm using a self-built machine with a micro squirt controller in test mode. Okay. You've seen coated exhaust valves. Most of the valves I've seen are the face is coated, like when they coat combustion chambers. I have seen some stem stuff for anti-wear, and I don't know if that would be like a DLC that they would put on that, but I don't know if stem wear is a concern for race applications. I remember back in the day when all the coatings were coming out, it was it was going to be the end all thing. Everybody has to do this to all of their stuff. Everything has to be coated. You have to coat the cranks. They were coating bearings and all kinds of stuff. And again, it's another example of like when we were talking about using a scope to determine what the strength of ignition energy is of your ignition system. If you see that and go, oh yeah, look, I want that because it's more right here and it's better. Except that when you dyno test it, it doesn't show anything, because even though that's better, it's like the analogy that I use is like a throttle body. So we know we have a stock 5.3 or a cam 5.3 like we ran with that L33. We've got a intake combination and it runs well and it makes good power. And then we know that the stock 78 millimeter factory throttle body does not flow anywhere near as much as a 90 millimeter throttle body. So we put a 90 millimeter throttle body, it flows more, right? It's got to make more power, except it doesn't make any more power because that particular thing is not the restriction. So we see the same thing with the spark energy in the system that we see with a scope. Yeah, it's more, it's better. It's got to make more power, because it doesn't translate into power in the same way that the additional airflow doesn't translate into power, because those two things are not the things that are limiting power production. That's how you find out how to gain more power. You find the thing that's actually limiting it, and then you change that thing. Karlov, I think part of your problem is the system that you're using for testing is not the same as they are. It's like using two different flow benches or two different dynos, not just different dynos in different places, but different styles of dynos, or definitely different styles of flow testing. So if they test it one way on one machine and you're going to try to compare that, you have to test that the same way that they do. Otherwise, there may be a difference. Or you can cryo treat stuff. Yep. Ceramic for combustion chambers. Yep. I've heard that. Although guys are, again, the racing teams have gone away from that. They're not using it. Gabe, what's up? In your opinion, what is the one thing people waste money on when they're building an engine? Well, I think I would have to argue the first thing is that they're building the engine instead of just getting one from the wrecking yard. In a lot of cases, you don't have to build a dedicated engine. And I've gone through this a lot because back when I was doing the Mustang stuff, we could go to manufacturers and they'd go, "Hey, look, we'll put together a short block for you so you could use it for testing. Just mention our name." They're not saying, "Hey, you have to say nice things about us," because that's just foolish. In the 30 years that I've been doing this, I've never had anybody from a manufacturer walk up and say, "Hey, look, we will give you money if you say nice things about me." First of all, that's never happened. And the second thing is, if something like that were to ever happen, I would just laugh in their face because that's not a reality thing. But having a brand new short block to test with is cool because then we can run stuff over and over and over again. But the reality is that, do you need to do that? Do you need to have that? Do you have to have brand new pistons and brand new rods and brand new crank and a forged crank and a freshly machined block and new bearings, rings, and all that stuff? When we go to the wrecking yard, will that cheaper way to do it solve all of the problems that you have? Like, what is your goal? If your goal is to make, if you want a 400 horsepower running motor, that's at the wrecking yard. And if it's not, that's at the wrecking yard plus a camshaft in any LS form, probably small block Chevy, although maybe not 400. You have to do more than that to the small block Chevy. Certainly to a big block, that's there. Can you achieve that? And is cost a concern? And if it is, that's the way to go, and not building one. If you build one anymore, especially any kind of street motor, I'd never put a forged crank in it, because given what we've done with all of these crazy things that we've done and run boost on and run RPM on and never heard a crankshaft, I would never get a forged crank because I think it's just not necessary, especially for like a build, a street motor kind of thing, even a street strip motor. And all of the things back in the day when we were doing this, oh yeah, I'm making 400 horsepower, 500 horsepower. It's got to have a steel crank in it, because all of the original factory, like the big block stuff, all the high performance ones, they all got forged cranks in them. Got to have a forged crank at 450 horsepower. That's a 5.3 with a cam in it. That's, but back in the day, that had to happen. Have you done any testing on sprint car motors? No, I don't remember. I've never done anything because I don't do stuff. I don't test things at that level because it's, the audience for that is very specific. So I'm not, I would love to go somewhere where somebody had put one of those together and run it on the dyno, and then I could just do a video on it. That would be great, because those are very cool. But I have not put one together again because it's not really my market. And I can't remember if the guys at West Tech have ever run one of those. I don't remember being there when they ran one of those. Straight methanol versus boost juice. What are you trying to, on what application? There would be no benefit for either one of those on an NA motor. Although I take that back. On some, some there might be. We've seen it gain on Coyotes and maybe LT motors. My suspicion is that straight methanol, if you're using it as a cooling agent and as a fueling agent, the methanol probably would be better. Billet crank is for repeat engine building, seasonal. In other words, I don't know what that is. So you're saying that you put a steel or a billet crank in so that you can use it over and over and over again. But for most of these guys, that's not a reality, because a billet crank is going to be several $1,000s. And if it is, that's like 10 motors from the wrecking yard. And so 10 motors is going to last you your lifetime, basically. Twin turbo 5.3 LS, no intercooler. Well, first of all, intercooler would be my choice over either one of those. And then the other two would be secondary. And I haven't directly tested those two things. With either one of them, I wouldn't be worried about what sort of power gain that they would give. The methanol should give you more power. The problem you're going to be having is, how do you determine your optimum air fuel if you're combining two fuels? So if you're running on gas, like it sounds like you're wanting to run on pump gas and then use this cooling agent and octane enhancement with this injection. So you have a couple problems. One, the first problem is, if you're running, let's say you're running under boost, you're running 11.5 with your pump gas. That's fine. And now you're augmenting that with methanol. You've added more fuel, but you haven't added it at the same air fuel percentage that you had with your regular gas. So you've got to figure that out. What is my right air fuel? Because you have to add a lot more methanol to get the same relative air fuel as your gas. But it is going to skew the air fuel reading. So it's going to skew it incorrectly. The methanol will add octane. It will add cooling, both of which are good. But the other problem you have with that sort of injection, depending on where you inject it, if you don't inject it individually as a direct port setup, you're going to have distributions, and distribution issues. Is all that going to be getting equally into all of the runners? I can tell you right now, it won't be. And then how much it won't be is going to vary depending on the intake that you use. So that's why an intercooler solves that problem. It solves all of those problems. It's a better cooling agent. It will make more power. It will be safer, and it will have better distribution than either one of those injections. But if you're going to use those, then you have those issues to deal with. Carla, my suggestion would be to take the data that you have and compare it to a more normal flow bench and see how it flows. If you find out that the flow data that you have is perfect and consistent, it's just different than what you get on another bench, then you know that your data is also right. It's just different than the way that the other people are flowing it. Meant cold air intakes, high dollar coils, crazy spark plugs, intakes. One more things waste money on. Small things are, well, coils I would never spend money on. Like if it's an LS application, I'd never spend money on any aftermarket coil. I'd never spend any money on any aftermarket plug. I mean, you might put a different plug in if you're running boost on it, but on a stock motor or on an NA motor, I wouldn't. I would just change the plugs if the plugs were worn out, and I would just put another plug in it. I put on whatever's on sale. Same with plug wires. I wouldn't change the plug wires. An air intake may or may not be useful. Cold air would be a must, but the air intake system itself, I haven't done chassis dyno testing on those to see what they're worth. Definitely is power to be had on tuning your setup. So if you go to the chassis dyno and you have somebody change the factory tune to something else, if that's available in your area, then there's probably power to be had from that. Shorty headers, I would not put on. Unfortunately, you won't find any old cranks like 400 Mopars in the junkyards. Yeah, I haven't seen any 400s. Tunnel ram over carburation was running a 327, forged crank, 283 heads, comp cams, thumper cam, top of the line, tunnel ram, Demon 575s, approximately 38 degrees timing, pump 91, no stumble, ran great until, did you lose a main cat bolt? Oh, it backed out and destroyed the bottom end. Would downsizing jets or smaller carbs pick up power? You would want the nice thing about carburetors though is they're going to flow the amount of air that the motor needs. So if you have more carburetor than you need on the tunnel ram, what will happen is you're just going to need to jet it. What will happen is normally on that setup, you will need to jet up. If you have over carburation, the signal is bad. It doesn't draw as much fuel. And so normally it's just like with a single plane, we have to add jetting to it to get the airfield to be correct. So you need to figure out which way you actually need to go. 575s, the thing that's on that combination, I don't know what camshaft, a comp cam, stumper cam. The 283 heads are the thing that are limiting you in power on that combination anyway. I would put different heads on it. Those are really, really small pore flowing heads unless they've been extensively ported. But better fuely heads or something on it would be a better combination. It would definitely make more power. But you need to find out what your air fuel is when you're running those and then just jet it accordingly. The wrecking yard loves me. This I know. Because the wrecking yard gods told you so. Is there a rule of thumb on boost versus spark plug gap? Yes, there is. You should run 19 or 20 thousandths plug gap when you're running boost. That's the rule. FR 260 LS3 heads, 454, operating up to 7,000 RPM. This product is street legal in 50 states. So, I mean, is that just a product statement that you're making or something? Or was there a question involved? Ten thousandths plug gap power gain was a ground strap being bent back to open the spark. So that's how you change plug gap. Is you change the distance between the ground strap and the center electrode. That's how it's done, right? Poor flowing heads on a Pontiac 301 are worse. Are they worse than I'd like to see a flow comparison between Pontiac 301 heads and the 283 heads. I know the 301 heads are weird because they have Siamese ports, right? Remember the old school Chevy 327 motors? Yeah, I have videos up on both the L76, which is the 365 horse 327, and the L84, which is that motor, but the fuelie motor, basically, with the fuel injection on it. They all had this, all 327s had the same stroke. Some of them had different main bearing sizes, I think. But they all had 250 strokes in them. 15 thousandths for 60 psi. That might be the plug gap that you need for. I've never run anything at 60 pounds of boost though. 60 pounds of boost is a lot. That's like getting into diesel territory. So we're going to go ahead and close our poll out at 53%. So getting closer to even now. 53% are saying that you should indeed coat the center with Glyptol of the Valley on the big block 396, 375 horse. So go ahead and close that out. Center 2 ports share the exhaust port. Here we go. 350 blows the 327 away. If you see the video, I compared the 302 and the 327 and the 350. The 302 and the 327 basically had the same parts on it. They had different, because I used the correct casting number heads on those two builds. But they both had fuelie heads on them ish. They both had small chamber, big valve. Like I said, the right casting number head. That makes any difference? It doesn't really, because all the ones that I flowed within a couple of CFM of each other. They both had the same Duntov cam in them. The 327 and the 302 did. They both had the dual plane high rise, although they were different. They both had, we ran them both with a 750 carburetor. They would have come with 780s, but it was a bit of vacuum secondary. They both had long tube headers and stuff. And oddly enough, they both made roughly this kind of similar peak power numbers. The 350 LT1 made a similar peak power number, but the 350 had much more average power than either of the other two. The 327 had more average power than the 302. The 302 made peak power a little bit higher, as you would expect, being a smaller motor. But they are all kind of limited in their. It would have been interesting to run that Duntoff cam in the LT1 and see what happened. Or swapping a Grand National motor. I don't know if I've ever seen a 301 Trans Am motor. I don't think they've ever run one of those on the dyno. Ken Croce from HO Racing has run a lot of Pontiac things there, but I don't remember him ever running one of those. So I don't remember seeing one of those factory turbos, specifically the flange, the header flange, the exhaust flange on that, to see what it looked like. I know it was weird and it was dedicated for that turbo, which is not uncommon for the OEMs to do stuff like that. It'd be better if it was just a T3 or a T4. It'd be better if it was a T4. The 89 Turbo T8, yeah, that's a whole different one than the 301. That's a Grand National engine. I've seen many gas engines make more than 60 pounds of boost. They have them out there, obviously, but that would be much less common than the diesel stuff. 2 more minutes. Milo's over here snoring. How Milo? He's having dreams, probably chasing squirrels. 1970 LT1 was maybe the best small block ever. That's one of my favorite years because I had a 1970. My first car was a 1970 and a half, as all the 70 guys will tell you. Split bumper rally sport, but it was not a Z28. It was not an LT1. People forget about the 301 turbo engines and the Trans Am. Smokey, the Bandit 2. Yeah, they did use the turbo version in that. Don, it's an interesting theory from somebody who wasn't there to see what it was and all of that. LQ4 with Truck Norris and 4L60. Should I swap to a 4L80? Did your LQ4 come with a 4L60? Was that a combination that they actually offered? I'm curious how many horsepower you gain with the Mongoose LS3 heads that are smog legal. Oh, so that was the question. I don't know why those would be any different than the other LS3 heads. The thing and this will be the last comment for today. The thing I could tell you about ported LS3 heads, regardless of what they are, if you take a look at the video I have up on where we tested 10 or 12 LS3 heads, you can see that the first thing is you need a lot of motor to take advantage of ported LS3 heads, because factory LS3 heads on the motor that we tested on made getting up between 650 and 700 horsepower. So, but they'll only do that on a motor that needs that. We had a 468 with a big camshaft in it, lots of compression. I think we had a single plane intake manifold on a big mast intake manifold on it and stuff. And so we had the rest of the combination that could utilize all that flow and utilize the flow of ported heads, because some of those ported heads could be 350, 360, 370 or more CFM from those ported heads. If you just put those on a stock LS3, which we did that test, we gained 10 horsepower. Does that mean the heads are only worth 10 horsepower? No. Does that mean they're worth 50 or 100 on the right combination? Yes, they are. As long as you were restricting it with the stock heads and then cured that restriction problem, because the motor wanted to make 800 horsepower, and then you were stopping it from making 800 horsepower, and then you put heads on it that would allow it to make 800 horsepower, then it will. But the thing is, most guys that put those ported heads are looking at getting the power gains from their LS3 that they got when they put ported cathedral port heads on their cathedral port motor. So if you put ported cathedral port heads on a 4.8, same thing. You're not going to get a big gain in power because a 4.8 already has a lot of cylinder head, relatively speaking, because it doesn't make a lot of power. But if you did that on a 408 with cathedral port heads and you had stock ones and then you put good heads on, you could take a look at the cathedral port head test that I did. On some of those, you can gain lots of power compared to a stock head. So the test motor that you test that on is going to dictate like how much power you get. And it's not that the ported head doesn't work. It's just that you're not doing your part to take advantage of everything that ported head has to offer. And on that note, it's time to go. I've got to go do the video now on find out what lift is worth. So how much power is lift worth? Basically, we're testing the Truck Norris low lift cam versus the Truck Norris higher lift cam. Not even a high lift cam, but a higher lift cam. It's about 50 thousandths more. So how much is 50 thousandths lift worth on a 5.3 liter that we ran it on? And then also we're going to show you the red hot cam versus a sloppy stage 2 probably to see what the red hot cam has to offer on this 5.3 liter. Thank you guys for watching, and I will see you guys all tonight. Pow. Lots of pows going on.